Okay, I'm going to work through the last part of notes here for the 3.2 section on least squared regression line. I left off on interpreting slope and y-intercept, and we just have a couple more things to talk about here. Should only take about 10 minutes or so. First one is residual. What is a residual, and how do you interpret a residual? Okay, so by definition, a residual is the difference. Oops. The difference between an observed value and a predicted value. So there's a little acronym I like to use to help you guys remember this. And since it's AP Stats, we're going to use the acronym AP. And what AP stands for is actual minus predicted. Okay, so you're going to get actually what happened, actual data minus predicted data. And the predicted data is from the least square regression line. Because remember, the line that goes through the scatter plot, those are all predicted values. So anytime you are working with that line in your least square regression line in the middle of your scatter plot, those are all going to be predicted values. Okay, and it's the difference between an observed value and a predicted value. So if you go back up to the scatter plot here, and I was going to talk about residuals a little bit. I don't know what just happened, but here we go. Okay, each data point has a residual. And the residual is the distance between the data point and the line. Okay, so all you're doing is calculating the vertical distance between each point and the line. So for example, this residual, it's this distance. You're talking about from this point to the line. How far is that? That distance is residual. This point. How far is this point away from your least squared regression line? So this distance right here you're calculating. Okay, if you're above the line, take this point. The residual is the distance between the data point and the line. And if you notice, you're always going to be working with your y variable because you're trying to calculate this distance. This distance right here. How much soda is between this point and this point? So you got to do some calculations. How much soda is between this point and this point? How much soda is between this point and this point? And those are your what are called residuals. Okay, and how you calculate that is you take the actual data minus predicted. Okay, so we're going to go over the calculation and the interpretation in this example. It says calculate and interpret the residual for the can that was tapped for 4 seconds and had 265 milliliters of soda remaining. Okay, so the first thing you have to remember is when you're doing residuals, you're doing AP, actual minus predicted. And then you're only thinking of your y variable, which in this case is milliliters of soda. Okay, in the problem, they give you data. 4 seconds had 265 milliliters of soda remaining. That is your actual data. That's what actually happened. Okay, and again, you're only doing the y variable because you're trying to find that vertical distance, which in this case was 265 milliliters of soda. So your actual is 265. You have to subtract predicted. Okay, so now here's where you got to kind of think back, and you don't have the predicted value. Okay, but you do have an equation to represent the predicted value. Your equation was right here. This equation, remember, this equation represents the line. So you're going to be using the equation to calculate the predicted value. Okay, because this equation is the predicted line, and you have to calculate the predicted value. So I'm going to take my equation, amount of soda, predicted amount of soda. Remember, the hat means predicted, is equal to 248.6 plus 2.63 times time. So I'm going to use my least square regression line equation to calculate the predicted value. And I have the time. I want to know the predicted value at 4 seconds. So I'm going to take my 4 seconds, plug it in for time. So after 4 seconds, I want to know how much soda is predicted to remain. So quickly, I will do 248.6 plus 2.63 times 4, and I get 259.12. Okay, that is the predicted amount. And what actually happened was I actually got 265. So now my residual, I take the 265, subtract the predicted, and the difference is the residual, 5.88. Okay, so that means at 4 seconds, the line predicted 259.12. I actually got 265 milliliters of soda remaining. Do actual minus predicted. If it's positive, it's going to be above the line. If it's negative, it's going to be below the line. And that is how you calculate the residual. So just a kind of a visual description. I was using the point at 4 seconds here, 265. So I believe this, so here is my 4 seconds. And 265 was right here. So I was calculating the residual of that point. Okay, at 4 seconds, this was 265. 4 seconds, 265 milliliters. I calculated the prediction. The prediction on the line was roughly 259. And as you can see, the amount of soda remaining was above the line. And the question is, how far above the line was it? That's what you calculated. You calculated this distance. That distance happened to be 5.88 milliliters. That's residual. And then last thing is interpretation. I kind of ran out of room here, but how you would write that out is, let me delete this quickly. So how you interpret this is this can had 5.88 milliliters more soda remaining than expected based on how long it was tapped. Okay, so if it's above the line, you want to include the word more. And again, expected is just the predicted value. So this can had 5.88 milliliters more soda remaining than expected. Also notice how I put in context here. Soda, based on how long it was tapped. And that would be your interpretation. We already talked about this. Least square regression line resistant to outliers. Actually, I'm gonna skip this for now. I was gonna show you an example, but we'll skip this. All right, this brings you to homework 59, which I believe is the third homework assignment for chapter 3. And then we will have one more note section here before the end of the week. If you have questions, let me know. Email me. Otherwise, just keep working on your homework.